3. All right, let's go. So in this video, I'm going to talk about a few examples. And when you're in grade 11, you're discussing functions and you're learning about kind of extending domains and ranges, and then talking about finding the inverse of a function or of a relation. You know, you obviously want to be exposed to several examples. Now, I have done a video on domain and range. I can put up a link up above there, as you will see it. And I've also done kind of a video talking about finding the inverse of a function or of a relation. And I can put that link up above there. But ultimately, you got to be able to try a few examples. And I figure I might as well put out this video to try to help you through some examples and show you that sometimes these things are not always that easy to do. And sometimes you may not be able to do it at all. And you might need to utilize some other tools. So let's get started. I have prepared a few examples that we're going to try to knock off. So example number 1 is basically just a plot that it gives us, and it gives us a few points. And it's asking us, and I'm going to ask the same question for all of them. And it's asking, you know, find the domain, the range, and then, you know, the inverse if it's possible from the given plot or from whatever is given. And then the second thing is, you know, state if the inverse is a function or not. So we do have to kind of understand, and I want to try to push you a little bit to try to refresh you on, like, okay, do you really know what these domain ranges and inverses are, and when are they functions or not? So whenever I'm given kind of a plot, the way that I approach these questions, I like to first kind of scan through the plot and possibly create a table of values. Because if I have a table of values, if it's just from given points, then it's much easier to find these domain and ranges that I will have. So if I create a table of values here for myself, and I'm going to do that right now. So let's say here is my x and my y. So I basically have, you know, my independent variable and then my dependent variable, which is the y. And now I have these points. So here's my kind of first point. I'm going to go from the left to the right so that they x is basically getting bigger as we go along. So the first point for x is really just negative, I guess, 3. And then the output was negative 1. So that is my first point. My second point, so this one moving over, which is negative 2. And for that, it would be 3. So that's that second one. Now, the third one, which is going to be, I guess, negative 1. And then it's going to be 1. Then the fourth one, so this one right here, so it's 0, 2. So it's 0 and 2. I'm going to have to extend this a little bit here. Let's do that. Then I have this one, which is going to be at 1. And that's going to be, I guess, at minus 2. And then finally, I have one at 2. And that one is at minus 3. All right, so I'm just reading off these particular points. So now I have created my table of values. Now, when they're just points and you want to find the domain, so please remember, okay, so what was the domain? Well, domain is defined as, so, you know, these double dots equals, so it's defined as, remember, it's a set. And in this case, because these are just points and I have a finite number of points, so 1, 2, 3, 4, 5, 6, I have 6 points in total here, unless I messed up. All right, so I have 6 points. So my domain is, okay, so what is the input, right? What values can the input or the independent variable take on? Well, it looks like basically, so the only values I have, so it would be just a set from negative 3 going all the way to 2. All right, so this is, you know, one way of defining the domain. Now I could be, you know, a little bit, I mean, I can create it and make it kind of not necessarily uglier, but different, but it would mean exactly the same thing. I'm going to write this just so that you have it for your own kind of viewpoint. So notice that all of these values are just integers, right? So what I could have said is that the domain, so x, is an element of the integers. Now integers we write with capital I or capital Z. I'll stay with capital Z, so either or is fine, such that, and now I am actually restricted, okay, or I'm restricting the x to be between, so here, so -3 and then 2. Both of these are exactly the same domains. They're representing the same thing. So here I'm being specific, right? So x is an integer, and then it's an integer between -3 and 2, inclusive. Or I can just write them out here because it's a very small set. If the set was much longer, you know, if I had 20 or 30 points, then probably this method would have been a lot easier to do instead of writing all the different numbers that I would have. So that's the domain. Now, what about the range? Well, the range, so I mean, I can pick off the range from the actual table of values, and that's kind of the nice, neat thing about this table of values. So here's my range. And again, I can write my range in, you know, different ways. So here's my range, and I'm going to define it. Again, it's a set, so we need those braces in there. And again, so I can basically just kind of see and check. All right, so if I take, so my smallest one, I guess is -3. So here, -3, -2, -1. I had, what else did I have here? And then I had 1, 2, and 3. So 1, 2, and 3. And this would have been my range. Now, if I wanted to write this range kind of in this format as I did above here, you know, so I could write this again. They're all integers. So now my output y is going to be an element of the integers. So again, z or I. I'll put I this time around. Okay, it doesn't matter. It will, I guess it will depend on whatever your teacher does, you know, later on. As I studied math, you know, we typically just utilized capital Z, but capital I is fine, and you sometimes do see it. And so here, what I would have to do is, I can't just say, okay, so that my y is restricted here between, I guess, 3 and -3. This would have been incorrect, because notice I am actually missing 0 here, right? So if I wanted to be complete, I almost would have to put a comma here. Now I'm running out of space. I'll put it at the bottom. But y, I guess, is not equal to 0. All right? And this would have been another way of representing the range. Now this one is probably more convenient this time around, so that, you know, whoever is the viewer can see it. All right? So that's what we have for the domain and ranges. Now, what about the inverse, right? And, you know, so from the plot, what do we know about the inverses? Well, the inverses, remember, they're nothing else but just a reflection along the y is equal to x line. Now, as a reflection, that's kind of an abstract thing. But remember, what it means is, you know, an inverse is always, you know, so if you have your input in here, so this was your x, you know, here was your output y, then an inverse was really, you know, another box in here that would do whatever it needs to be done to return your x back, right? So it reverses the process that you have. And so since in here, so these ones are mapped as x, y, so these points are in here. So the easiest way, whenever you have these plots, and they're not actually actual functions or relations mathematically written out, then what you do is you just simply swap them, right? So we just swap y and x, and then here's your inverse. So your inverse within here, so all you would do is you would just swap these two around, and then you have an inverse, right? Okay, so I mean, I can write this out again. Okay, so in here, so if let me delete this out, and I guess I can, you know, I'm going to make this a little bit smaller so that I can see it. And if I swap these out, so what I would have now, for my inverse, so that would have been -1. I guess I can kind of write them out I'll write them in exactly the same way, just so that you see it Now you can rearrange them from smallest to largest if you wanted to. So this is what we would have. This is my new kind of x, right? And this is my new output y, and then they're just swapped with each other. So this would have been -3, -2, -1, and then 0, 1, and 2. And now you can plot these up on the actual plot itself as well. You know, so these particular points. So what you would have, if I switch the color, and let me clean this up here. So if you had this, and let me switch the color, maybe something that stands out. Okay, so this right there. So notice, so the first point is -1, -3. So -1, and then -3. So here's a point right there. Okay, so that's the first one. Then it's 3, -2. So 3, -2. So that's another point right there. Then it would have been 1, -1. So that's another point right there. Then it's 2, 0. So 2 and 0. So that's another point right there. Then it's -2, 1. -2, 1. So that's another point right there. And then 2 and -3. So that would have been 2, -3. So it's going to fall on, 2 and -3. It's -3 and 2. So -3 and 2. So that's right there. And notice that now, you know, because for an inverse, okay, so what we have, so basically, you know, this line, which kind of is y is equal to x. I guess I don't have to go further than that. And all it does is just reflects these points, okay, so that you have them. So they're just a reflection of each other. So for instance, you know, if you have, okay, so right here, so this point right there is reflected by this point along that y is equal to that axis. This point right here is reflected with this point is reflected with that, and you get the gist of this. Now, is this a function, right? Now, what has to happen in order for it to be a function? So does this inverse actually exist? Well, the answer is yes, okay? So in this case, it does exist. Now, you can think of it as trying to do the vertical line test, or you can, the other way of thinking about it is, does each kind of input that you have, at least input for the inverse, does it give you a unique output, right? So it can't have multiple outputs which are coming from the same input. So no matter which vertical test you do, right? So if I do, let me draw my line here and I'll put it in pink, maybe not in pink because that one we used there. So let's do something that is a little bit off and different, maybe blue. Okay, so notice that, so here, okay, this is the vertical test, or basically the uniqueness of that inverse, right? There's only one point in that line. And then the same thing happens since we're only dealing with integers. Here is only one point. Those are the green points that I have. Here is only one point. Now in this, at 0, there's nothing. Here, there's only one point. And then here, there's only one point. And so on. So here is only one point. Okay, so if it's unique, if there's only one point in that vertical line, meaning one unique output, then it is an inverse. If it happened that, you know, you had 2 points, so for whatever reason, if you plotted another one and it had 2 in that vertical line, then it's no longer a function. So that inverse is no longer a function. And typically would say, you know, then the inverse really doesn't exist. I mean, that's the inverse, but it's not a function. So that's the first example, and I thought to share this with you because it's a great example to really push you and make you understand, you know, these domains that they're sets, these ranges that they're sets, and then the inverses, you know, how can you find them? And all you do is you just swap your x's and y's because you're reversing the order, right? That's what an inverse actually is supposed to do. So here is another example that I have for you. So again, it's a plot, but in this case, it's a line. And this particular line that we have, so that line is kind of stuck between 2 points, so between these 2 points. Now I can write these points out. And so my point, so the one on the left-hand side, I guess it's 1, 2, 3, 4. So it's -4, and then it's 1, 2, 3. So that's that point. And then this point right here is, I guess, 1, 2, 3, 4, 5. So it's 5, -1. And it's a straight line. Now, for straight lines, now in this case, it's restricted because it's between those. So if we want to find the domain in here, so the domain that it lives, so the independent variable, so basically it's between here and here, correct? Those are the only inputs that I would have. And then my range, okay, so my range that I have in here is basically any points that lie within here. So that's my range. So now I can represent these. So my domain D, okay, if I would read it off from the graph. So now I will write it, okay, so notice that these are not integers, they're not sparsed out, they're actually just a kind of a continuous line. So it's going to be the real numbers, like it includes all of them. So I'm going to say that x, okay, is an element of the real numbers r, so capital R, I write this funny r, such that, now it is being restricted, right? So it's between -4, x, and then 5. And that's my domain. So those are the only numbers that are allowed as my inputs in here. Now, what about my range? So for my range, what I have, if I wanted to define my range, now in this case, so what I have is now my range, so my output, I guess I'll call it y. Okay, it's again the real numbers, okay, so capital R there, but it is living, I guess, between -1, and then it is bounded by 1, 2, 3. So it's bounded by that. So that's my range. So those are all the possible outputs that I have, and then all the possible inputs. And again, they're a set. So that's the correct way of distinguishing these if you wanted to write them out. Now, what about an inverse? So in the previous case, I did a table of values. Because we're dealing with the real numbers, it's a continuous line. I can't really put a table of values only because they're not just, a finite number of points. You don't have a finite number of points. You have an infinite number of points because between these points, -4, 3 on the top left, and 5, -1, it includes all the points on that line. So if you wanted to find an inverse, you wouldn't really do it through a table of values. Now, this is a line, and for lines, it's actually not bad to find the inverses. So the first thing is, let's maybe find what this line actually is. Now, we know that a line is always in this form. Now, if we know that a line is in this form, all I really need is 2 points, but I have 2 points, so I can find the slope. And then I can find the y-intercept, so the b in there. And then I have my equation of the line. Now, it has a domain, so it's being restricted between -4 and 5 on the x. But that's okay. And what I'll do is, okay, let's find this line and then find the inverse. Okay, so how do I do that? Well, my slope, okay, so here's my slope. I'm going to find it, and I'll do it in fast forward fashion. And then I'll find my b. Okay, so we can do that as well. So I'll find those two. So we'll be right back. All right, so there you have it. So I just found the slope, then I found my intercept. So that's something you should be familiar with from grade 9, and then also, I guess, kind of beginnings of grade 10. And, once we have this, so now how do we find the inverse? Well, for the inverse, so don't forget, when you have just lines, all you're doing is you're just swapping your x's and y's, just as you did in your table of values. And then, so really, you just have to re-isolate this to find the inverse. So now we're going to solve for x. And when we solve for x, then we're going to find what the inverse is. So in here, so what I'm going to do is I'm going to realign this and I'm going to solve. So y, I'm going to bring this over, so 11 over 9. So that I'm going to bring over on the other side. It's going to be negative 4 over 9x. Okay, and then so within here, so now I can multiply. So this is, it's going to look a little ugly in here. So I'm going to multiply both sides. All right, in this way. So that gets rid of this. So I basically re-isolated this. So now what I have is I have negative 9 over 4y, and this is going to become positive. Okay, so these 9s and 9 will cancel here, and I'm going to have 11 over 4. All right, so here is my inverse. Now this looks kind of weird because you're written it out in terms of x, and don't forget that we have to swap these, right? So the y and the x have to get swapped. So my inverse overall, so what it is, let me maybe add a page here, just, okay, so I have a little bit more space. So my inverse overall, so if I swap these two, then my inverse function, or I'll write it maybe as an inverse function like this, so that would have been that, it's equal to negative 9 over 4x plus 11 over 4. And really what I did was, so this is just a swapping, so don't feel like it's anything different. So that's what you would have. Now this inverse, however, also has a domain and a range, right? Because it's not infinite. You know, it's not for all your inputs in here that you have. It's not for all of these. So how would you find the domain and range of your inverse? Well, the nice thing is that when you're dealing with linear, okay, so when you have just basically a line, once you have found your domain and you found your range for your original line, then all you do is you just swap them. So now your range is your new domain, okay, for your inverse, and then your domain becomes your range for the inverse. So here, so if I take these, and this is the nice thing about doing these, and then, you know, you have to do this and convince yourself of it as well, and I'll try to convince you in a second. So now what you do is you just change these around because now you're dealing with the inverse. So in the inverse, okay, so what you have, this is now your domain, D, and now this is your range that you have. So they're now swapped around within here. Now, of course, okay, because we do that, then, you know, we are going to change these out. So this is going to be your X, all right, and then this is going to be your output Y, because you're dealing with the range and then the domain. Now, let's graph these so that just we can visually see it. Like, I know we have graphed it in here, and we see it, but I'm going to use Desmos, you know, which is the great tool that we have. Let's try to graph this out. Okay, so I'll be right back. I'm going to put both of these into Desmos so that you can see them. All right, so here we have it. I basically graphed it. The red one is the original one, and then the blue one that you see is actually the inverse. And notice, so what you have is they're basically just a reflection, right, along the line. So notice the y is equal to x, and they're just reflected back. So, you know, if I would do this, okay, so let me kind of take a picture here. All right, so here it is. And now what I want to do is, so here's, notice the reflection, right? Because it's much easier to see when you kind of rotate it back. Okay, so it's clearly being reflected. So, you know, for instance, you know, this point right here, it's being reflected along that line, right? So here's that. Here's the point here that's being reflected over here. So it's, you know, basically a perpendicular line, okay, that you have between this and this, okay, and it's just a straight out reflection. And, you know, so it's super neat to be able to kind of do this and then have tools like Desmos to try to plot it and then really understand, you know, the inverses. Because remember, inverse, all it does, it just reverses what you've done. So if you're inputting a number, then at the end, so after, you know, let's say in this case it was a line, then you go through the inverse, then you get that number back. And in this case, the inverse is indeed a function because it's just a line. And if it's just a line, then it is a function, unless it's a vertical line, right? So if it's vertical line, then it's not. But in this case, it has a slope, and that's how you would find the inverse and the domains. So I have, you know, here's another example that I have prepared. And this particular example is also a great example, and it kind of goes back. Now, it does not give you a plot. It actually just gives you the function. And it actually also gives you the restrictions, which is written out as a domain. So you have a function, capital F of t. So we're kind of used to x and y's, but I wanted to throw this in so that you see that it's not just x's and y's. So my independent variable, or my input, is basically t, and then my output is this capital F of t. So that's what we have in here. So here's my input, and then here is my output. So this is what I have. Now it is being kind of restricted. So here is this is actually my domain that they have written out for me. So my domain is restricted between 0 and 25. And that's what I have here. So let's try to see if we can understand, you know, what would have been the range here, and then can I create an actual inverse, you know, from a given function. Now, do you notice anything about this? So within this, you should kind of notice, although it's not written in exactly the same form, right? But you should notice that this kind of looks like a linear function. Except, you know, they've written out the slope in here, and then here is your y-intercept. So this right here can be written out in this way. So negative 0.8t and then plus 20. So those are the same thing. And here's your slope. And then here's your y-intercept. So this is another line, and it is being restricted between 0 and 25. Now, what is the range? Right? So if it's between 0 and 25, if you substitute 0 in here, you'll notice that the f of t, or f at t, when t is equal to 0, okay, so here, so if you substitute these, and because it's a line, that's another hint for you. You know, when you're finding out these ranges, when you're doing your quizzes or your tests, you can plug in, okay, these endpoints, and once you have those endpoints, they're going to kind of guide you along with what your range will be. So my first endpoint, so this is going to be 20, right? Now my second endpoint is 25. And if you plug in 25 in here, so 25 times 0.8 is actually 20, and now it's negative. So it's going to be negative 20 plus 20, which is going to be 0. So notice that what happens to this, now because it also has a negative slope, so this is really going from 20, which is indeed the y-intercept, and then it just goes straight down to 0. So my range, so you know, this basically is going to look something like that, right? Where this is your y-intercept, and then it will stop there at 0. So for whatever reason, and then this is your domain right here that it goes through, right? And your domain is from 0 to 25. So plotting this out, okay, you'll notice that it's basically just a graph going straight down. So my domain is between 0 and 25, okay, on the real values of t. And now my range, so if you wanted to write out my range, so we're going to take it from right here. So my range is basically defined as, now this is my output, so I'm going to write f of t. So I'm going to write it like this because that's what they're using. Now, as a student, I used to be, when they wrote this, I was so used to using y because we did everything in y and x. So do be careful because it's not necessarily just a y unless, you tell the reader that y is f of t. Okay, that's what you would want. So here I'm going to keep it as f of t. So now it's the real values, okay, such that, and notice that I am being restricted. And here I'm going to kind of write it in this way. So it's between 0, right? So it is bounded between these, and that is your f of t. And it is that. And I'm going to close this in here. Okay, so this is what we have. So f of t, and I apologize in here, so I wrote it out kind of in the wrong way, and hopefully maybe you caught it. So f of t has to be less than 20, but it has to be greater than 0. So it should be, these are the inequality signs that we should have in there. Okay, so in here it made sense, okay, to have less than or equal to, but here I have to put greater or equal to and greater or equal to in there. But it's still the same thing. Now, how you write it, you could have written it like this if you wanted to. All right, so this would also work because that's what f of t is, right? It's lying in that boundary between here and here. So it's between here and here. And I'm going to plot it for you as well. So I'll be right back. All right, so there you have it. So I plotted it. Now when you're plotting it in decimals, I do use y and x. And once we have that, so notice it is indeed that straight line going in there. Now let's imagine if we wanted to do an inverse, right, of this. So again, because it's linear, so finding the inverse of this is you just simply take the actual equation. So what you have, this is the beauty of working with linear equations. And again, so what we're going to do is we're going to really just isolate for this t, okay, because we're trying to reverse the process. And then we can switch, okay, so whatever that inverse will be. And so here, and again, these have to be switched, right? So your inverse, okay, so your inverse right there, so you can write it as f inverse of t is equal to negative 1.25. This becomes your t plus 25. Now, of course, it's going to have a domain and a range as well. But we talked about this, that for linear ones, all you're doing is, okay, you're swapping these. So that means your domain from the original function is your range. And then your range becomes your domain. So in here, so notice that what we would have is our domain for this one, okay, for this inverse would be t. So it is an r such that, now it's from the range between 0 and 20. There you have it. Now you can put the range as well if you like. And again, I'm going to plot it for you. All right, so there you have it. And again, it's going to be reflected, okay, along this line, right? So if you would, you kind of have to look. Strange, that's what I used to do as a student. Now I just kind of trust myself, especially when it's linear. Linear are the easiest ones to work with because it's much easier to find the inverses of these particular lines. So there you have it. I hope that within here, so now it is indeed an inverse and it is a function. You can do your vertical line tests. Okay, so indeed this is a function that we would have. All right. Now, okay, what I wanted to do is to finish this off. I wanted to not to scare you, but also to kind of make you really think that overall, when you have these functions and relations and you're talking about the domains and ranges, they're not always very easy. When you have linear, that's kind of the easiest way to be. But notice all of these are non-linear. There's all kinds of stuff happening. So you have 3 examples in here. And good luck, trying to find out domain and ranges becomes much, much harder to do that. All right. So I'm going to take a look at these because I don't want to make this video too long. Okay, so these are going to be the next set. It's going to be part 2. And I'll prepare that video to create domains, ranges, and talk about kind of inverses for these harder ones for you to give you some intuition. Okay, we'll see you in a future video. Bye, everybody.